Welcome back to the 7th video in the Haskell series. I will go through some syntax in functions in today's episode, and I will start with showing a basic implementation of guards as well as using where in our function. And so let's get right into the example. So let's say that we want to make a function, let's call it cube, which basically takes in the sides of a cube. So it's going to be 3 integers, and then it returns a different string depending on the volume that the cube has. And we're going to use guards to basically get these different outputs. So let's just say that we have our function here, and we have our 3 different variables. So these 3 integers. So let's say width, height, and depth. And the way that we would use guards in this case is that we would basically skip a line, and we would indent the code by pressing tab, and then we would do this large line here. And the way that guards work is basically that we have a condition, which can be true or false, and then we basically have the return. So if this is true, then we return this. And the good thing with guards is that we can have multiple of these. We could, in this case, have conditions followed by conditions followed by conditions. And this is very useful in our case. So let's say that we first of all want to calculate the volume of our cube. We would basically just take width times height times depth. And let's say that if this is smaller than, let's say, 50, then we return small cube. And then we can do the same thing again, right? We can add another one, and we can say that width times height times depth. And if this is smaller than, I don't know, let's say 200, we have a medium cube. And lastly, let's also say that if the volume is, say, smaller than 500, then we have a large cube. And then we can also just have basically a base case, you can say. So we have otherwise here in the end. So if our function doesn't fall into these 3 guards, we basically have something that's larger than 500. We can return enormous cube here. Even make it capital, enormous cube. Make it real dramatic. So let's say that we were to try this function. Let's say cube, where we have something which falls into that the volume is lower than 50. Let's do 3, 4, 5. Oh, that's actually larger. Let's do 2, 3, 4. Should be a small cube. And as you saw, if I did 3, 4, 5, that would become a medium cube. And then we can try something real big. Let's say 50, 50, 50. It should be a huge cube, and it returns an enormous cube. But let's actually say that what if I do cube in our case, and I actually send in a negative number, right? This shouldn't work in volume, because I can't have a side that has negative, or basically a negative side. If I do this, I get the return small cube, so this is not good, right? So we can actually add another guard here. Oh, we can add another guard. We can say that if width times height times depth is smaller than 0, then we return basically an error, and we say negative volume, which shouldn't be the case. If we were to run this code, let's say cube with, let's say, -1, 1 and 1, I would get an exception and an error, basically an error message, which says that it has negative volume. But what happens if I make 2 of these negative? Because this would, again, oh, but this should also return an error. So basically my guard here is wrong. So here I could actually add multiple. I could say that if one side is smaller than 0, or another side, so let's say h is smaller than 0, or d is smaller than 0, I return this error. Let's say that I were to write this and do the same with 2 negative numbers again, I would get the exception error message again. But let's see our code here. We have this calculation 3 times. This let's say that we had a very complex calculation with like complex functions. Then to make our code look a bit more nice, we can use the where. So here I can basically define. So let's say I can basically define this calculation. I can say that where volume is equal to, and then I can basically just do this. So I can take this calculation and say that volume in this function is basically equal to this calculation. And then I can take volume here, and I can basically just paste this in here. And this would basically just be a neater way to write our code. If I were to run the program again, cube width 234, you see I would get the same result as before. So yeah, this is just a basic implementation of guards, as well as using where to make your functions look a bit better. But guards is very useful, as well as the next video where I'm gonna go through pattern matching. These are very, very useful in Haskell. You use them a lot, and pattern matching is actually a bit more useful, I think. You use it a bunch in recursion and everything. But yeah, that's it.